as we work through our data sets today. All right. So the 5-number summary is a universally accepted term. When you say that statistically, people know what you're talking about. The min, Q1, the max, excuse me, the median, Q3, and the max. So you got Q0, 1, 2, 3, and 4, basically. Why do you think this gets a name? This set of numbers gets a name. What does this set of numbers tell you? 6, 9, 14, 20, 36. What can you get from that set of numbers? What jumps out at you? I'm going to clear some of the board over here. What jumps out? What data is kind of hidden in there?
The lowest number?
Yes! You get the minimum, which is something you do not get with an average, even with standard deviations. You get ranges. Within 1 standard deviation is like 2/3 of the data. Within 2 is 95%. Within 3 is a bunch. But it never tells you like this is the lowest, this is the highest. Good, I like that. Candace?
That's almost a graph in itself, just looking at it right there.
Almost. I like the word almost the graph in
Well,
itself.
I mean, if you have a graph,
No. I like what you're saying.
You can look at it, and that's a graph in
I
itself.
like,
Right
may I, if you don't mind. That's not you guys, that's the other class. Here are your guys' data. I like this map because it shows Alaska the actual correct size. So I had to do that. It drives me insane making you with that damn map in class with Alaska being too small. That's how big friggin' Alaska actually is. Texas is my butt. Okay. Texans, I apologize. Alaska's bigger. So what I want you to look at is, quite. So what I did up top, Candace, was I put the dot plot. Each one of you is in that data point somewhere. Each one of you is up there. Okay, it's a dot plot. So it's like a histogram. It's like that histogram we just drew with a scale of 1. So you got your 2 6s, your 2 7s, your 8, your 2 9s, your 11, and so forth and so forth and so on. Now, what statisticians will often do is they'll add a graphical look at the 5-number summary in what's called a box plot or a box and whisker diagram. Now you don't have to have the dot plot here. But since you mentioned it looks graphical, I figure we'll just throw it on top of the dot plot. And then I'll turn it off so you can actually see it in isolation by itself. But I want to put it up here with this first. So what I'm going to do, let me turn this back on, turn this off for a second. Here is your 5-number summary. 6, 9, 14, 20, 36. Those 5 numbers. I love when Candace said it's almost a graph in itself. The only thing that's missing, the only thing that's missing is the relative space between the numbers. For example, from 6 to 9, how much space is there? 3. How much data is between 6 and 9? How much of your data? How much? Better question. What percent? Go ahead, Linda.
There's 5 numbers.
There's 5 numbers, but there's 4 regions between those 5 numbers.
Yeah,
so 25%. Is that fair? I love what you're thinking. You're thinking fence. When you build a fence, you have one more post than sections, right? Because you have the damn post on the end. So you got post, fence, post, fence, post, fence, post. So there's 4 regions made up by those 5 numbers. There are 25% here, right?
Yep.
There are 25% here. There are 25% here. And 25% here. It could be 6, 6, 6, and 6. It could be 10, 10, 10, 10. It could be 1,000, 1,000, 1,000, 1,000. Whatever number it is, there's the same percentage of data between each of those little regions. Is that fair? Okay. Now the reason I love when Candace said, "Let's make a graph of it." Thank you, Ti, for turning yourself off. The reason I love what you said is because you don't get the scale of those numbers until you drop them onto a number line like this. For example, the minimum value is 6, the max is 36. So what I'm going to do is, I'm going to come, oops, makes a big difference, I can tell. I'm going to put a little mark there, and a little mark here, at the min and the max. Those are the ends of my box plot, or my box and whisker diagram, box and whisker plot, whatever you want to call it. I call it a cat face plot too, you'll see why momentarily. You then add bigger lines on the quartiles and the median. So at 9, 14, and 20. So 9, 14, and 20. Okay, so far? Getting there? Then you make a box out of those guys like that. And connect these guys out to here. Now, when you put that with the dot plot, I love it because you get the idea of the density of the quarters. Yeah? When you see the numbers 6, 9, 14, 20, 36, it's like, oh yeah, 25, 25, 25, 25. But 6 to 9 is only a distance of 3, correct? 20 to 36 is a distance of 16, more than 5 times more of a range. But it's the same number of points in that range of values, right? Which means the tighter regions show more tightly packed data. So, Candace, with your awesome idea of making it graphical, you've also given us a look at the variation of the data. When you look at the box plot, you can almost see the skew. Here, look, turn it off. You can almost see the skew. The long sides are more spread out than the tight sides. That's an awesome idea. When you put it with the box plot, it's even more descriptive. But I'm with you. I think it's a brilliant, brilliant, brilliant idea to do that. Is that fair? Yeah. So the box plot is a wonderful, wonderful thing. We're spending quite a bit of time today talking about them and comparing them too. I want to show you how you can stack them next to each other and actually do scientific analyses with them, which is even more fun, I think. But yeah, a box of whisker is just simply a picture of the 5-number summary. Now, there's nothing wrong with the 5-number summary. There's absolutely nothing wrong with these 5 numbers. Ba, 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 ba. But I think as humans, we're going to look at this physical space and think it's the same as this physical space because it occupies 2 lines on a computer printout. Whereas if you take those numbers and scale them on an axis like we did up here, you actually get an idea of, oh God, look, 1, 2, 3, 4, 5, 6 right there. 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 Oh, now we're all spread out, and you can see it. Got a laser pointer? Walk over to it. You've got this beautiful spread right here, yes? You got this beautiful spread. That is not at all obvious. It's not at all obvious when you simply look at the numbers stacked vertically on top of each other. Is that fair? You guys buy that? Maybe a little bit ish. Getting there. Questions you have? Not yet. That's okay too. It's all human-made stuff, right? It's all human. This is not the law of large numbers. This is not a coin falling heads and tails. It's not scientific observation. It's just a way for humans to grab a data set and talk about it in another way. That's all it is. That's all it ever has been, honestly. Cool? Just so you know, let me take this out of here real quick. I wanted to show you. So take a look at your data right there. That's your guys' data. This is yesterday's class's data. Comment on the shape. Say it again, nice and loud.
Skewed.
Very similar, skewed again, similar to yours. This is about 2 years worth of data. Very, very skewed. I lied yesterday. I said nobody had been to 50. Obviously, one person had. Yes. Highly skewed data. Highly skewed data. But it looks like it's like a larger version of yours. As when I took your guys' line out, here, you guys are this line down here. When I removed your guys' line, watch the overall curve when I delete all this. It like takes a line off the top of the curve. It's like icing on the cake.
Yeah.
And we put it back on, undo, boop, pops right back on.
Yeah.
It'll be fun to watch this grow over time and see how it changes over time. FYI, making a dot plot in Excel, as you may have guessed, is a total pain in the ass. If you ever need to, email me, I'll send you the template, just use mine. You have to use symbol menus, it's clever. But it's not worth you slugging through. If you ever need to make a dot plot for a presentation, just email me, I'll send you that. Or a box plot, which we'll get to momentarily. Making a box plot in Excel is not easy. But if you ever need a template, I can send it to you. I kind of figured out a cheat for it. Speaking of box plots and using technology, grab your TIs. Let's get it in your TI, which I think is more valuable than using Excel for class, for a couple of reasons. Number one, it's easy to do, and number two, you actually have a TI with you, as opposed to carrying Excel around. So, let's get these back on. So first,